Hi, this is Thomas from Apex Game Tools. In this video I'm going to showcase the Advanced Dynamic Obstacles package, which is now available on the Asset Store. Now, since the beginning we have had dynamic obstacles in Apex Path, but we are now adding these advanced dynamic obstacles in order to provide some more features. So let's get started showing you the different features. We'll start with the basics, showing you the difference between the standard dynamic obstacle and the new advanced one. So on the left hand side we have the standard dynamic obstacle. This obstacle is axis aligned, which means that when the object or obstacle is askew or at an angle like this, it will actually cover more cells, or it will block more cells than it actually covers. Since it is axis aligned, this is its bounding box. On the right hand side here we have the advanced dynamic obstacle, and as you can see, it only blocks the cells that it actually covers. Now the default behavior is that it will only block cells that it covers the center of, but you can adjust that to a different sensitivity, just as with the grid and static obstacles. So if you go to the dynamic obstacle, you have these two options. You can either use the grid's obstacle sensitivity, so that it will behave just like static obstacles, or you can set a custom sensitivity if you want it to be more sensitive or less sensitive. Now for the most part you will probably want to use the grids so that it behaves the same as a static obstacle, but in this case I'll just show you that we can change it to, let's say, 1. So all cells that are whose centers are within 1 of this dynamic obstacle will now be blocked by it. So as you can see, now it blocks quite a few more cells because each of the centers of these cells are actually within 1 of the dynamic obstacle. So moving on, next example. Oops, that was the wrong one. Basics gone, and we just show you a door. It's the same thing pretty much. As you can see, we have a door at an angle, and it just blocks the cells that it covers. Otherwise it works just like a normal door. Had this been a normal dynamic obstacle, it would have blocked additional cells, these two. Alright, so moving on once again. Now we have both movement and rotation supported by these dynamic obstacles. So in this example here you can see we have some rotating stuff. On the left hand side you can see this is a mesh collider, a mesh that is actually rotating, and this is just a simple box collider rotating. I will get back to how the settings are for these in just a second. I'm just going to show you one more thing. As you can see, there's also a visualizer that shows you the actual bounding, well, not box, but the bounding polygon of these obstacles. This is just a debug visualizer that you can use to set up how you want your obstacles coverage set up. So now let's have a quick look at how these are set up. So I have two different ones here. We have the blade, I called it. This is this one over here, and it has a dynamic obstacle. And what makes this an advanced dynamic obstacle is that it has a bounding mode set to adaptive. Now there are 3 options. Axis aligned, this is the default mode. This is the old or standard dynamic obstacle mode. Adaptive means that the unit will adapt basically to how it is, the rotation, size, scale of the unit, and speed of the unit. And then we have a last option called fixed hull, which we'll get to in just a second. Another thing that we have here is something called adaptation rotation threshold, and this has to do with how the obstacle will calculate its bounding hull or its bounding polygon. This is kind of an advanced setting, but basically what it means is that if its rotation along the X or Z axis is less than this, it will use an optimized algorithm. And above it will turn to a more advanced algorithm that supports full rotation on all axes. 10 is a suitable value for the most part. Now for the other obstacle, the triangle, this is actually a mesh collider. So you can have all kinds of different meshes and use them as dynamic obstacles, although as with other meshes and collision detection in general, it is always a good idea to have as simple as a mesh as possible on your collider. Too many vertices and you will have problems with performance, and that goes for dynamic obstacles as well. So one thing you can do in cases where you have a dynamic obstacle that is not going to move as in have a velocity. I know this one is actually moving, but it's just rotating. If you have one that is simply rotating or changing its size, but otherwise it just keeps its normal form, you can use this other bounding mode called fixed hull. It only makes sense for mesh colliders. What it does is basically it calculates the bounding hull just once and reuses those vertices, which it can do as long as the unit doesn't move or the object doesn't move. And we'll see another example of how you can use this in another example. So moving on to the next one, this is actually the example where we can see this. As you can see, here we have the actual obstacle in the middle. It does not have a dynamic obstacle attached to it. It simply has the collider for the actual collision detection, and then it has a rotator that rotates it around. The actual dynamic obstacles are these triangles. So here I've just created a very simple mesh, just one triangle, and then the dynamic obstacle once again is set to fixed hull, meaning that it just calculates this once. So this is super efficient. So the idea behind having these two dynamic obstacles or triangles attached is that since this blade, it doesn't have a velocity, we cannot use the velocity prediction factor that is normally used when an object has a velocity. It will use that to predict the coverage or block area in front of it along its velocity vector. But since this one does not have a velocity, we do this instead. So basically these just act as a velocity vector. So as you can see now, it actually, when it rotates, it actually blocks cells ahead of it, even though this is not a collider. Well, it is, but it's not a collision. It is just a trigger. It's simply used to set up the dynamic obstacle. The units that will get in contact with this will only collide with the actual obstacle, this blade in the middle. So moving on once again, we have a moving obstacle. Now I'm just going to show you, and then I'm going to explain what the important parts about this one is. So now, as you can see, we have this car moving between 2 points, and it just blocks the cells as it goes. Now right now, as you can see, it doesn't actually block cells ahead of it, so it only blocks the cells that it actually reaches. Probably we would like it to actually block cells in front of it using its velocity. Now I've created this. As you can see, this car is a rather complex car. It has it's a rather complex mesh, so attaching the dynamic obstacle directly to the car would be very inefficient. It will need to calculate the bounding hull from a lot of vertices. But since the car is actually pretty much just a box, we've just attached another game object, added a box collider around the car, and then that is what will be used to actually calculate how the dynamic obstacle blocks its cells. But since it is actually a child object of the car, and the car is the one that actually has the velocity, that is the one with the move script, it will not actually predict any velocity because it doesn't know about any velocity. So in order to get it to know about this, you can simply tick this option down here, resolve velocity from parent, and it will do so. So now if we start it, we will see it will actually project the blockage in front of it using its velocity vector. So if you have complex dynamic obstacles, complex meshes that you want to use as dynamic obstacles, it is recommended to create, either you can just use the standard, if it fits within a standard collider, use a standard collider. If not, then create a simplified version of your mesh and use that for the collider. So you can have a mesh collider with a simplified mesh on it to use for the dynamic obstacle. This will improve performance by a lot. So, moving to the last example in this scene. So here we can see an object that does all three things. It moves, it changes its size, and it rotates around all the different axes. So if we look at, as you can see, the hull changes all the time, depending on how it grows and how it rotates. So there you have it. These are the features of the advanced dynamic obstacles. Obviously the main feature being that it is not axis aligned and that you have some different options on how the hull is calculated. Many of the options are optimizations so that you can get the best performance possible. And speaking about performance, I'll just end this by showing you this performance scene where we have hundreds of dynamic obstacles moving around the scene. So the scene is made up from multiple grids, and as you can see there are quite a few obstacles moving around. And there you have it. This is showing, this is the visualizer. And if we want to see, we don't want to see performance with the visualizer on. It's not exactly helping stuff when it draws the gizmos, but as you can see now we have all these dynamic obstacles moving around, blocking cells, and we have a performance hit at around 4 milliseconds per frame. And we have a frame rate that is, well, higher than it needs to be. So, advanced dynamic obstacles, even though they are advanced, they are also very high performant. So there you have it. Advanced dynamic obstacles. They are available at the Asset Store right now.